Good evening, everybody. Once again, it is office hours time again, my favorite time of the month. Good to catch up with the community. Although we can honestly say that the days of the only way of catching up, being over a video call, are coming to an end. People are starting to travel again. People are starting to go to conferences again. And hopefully we'll be seeing each other face to face sometime soon. If you've caught some of the previous sessions on today at Database World, thanks for hanging around, especially if you're in Europe, to come to my office hours session. Big office hours night tonight. I've got my session straight after this. There's an Apex one where they're talking about all the cool features in Apex 22. So yeah, a big night of office hours ahead. Therefore, I will definitely not run over time. If we run out of time, I'll pull the pin early such that you can get onto the Apex one for those people who are keen on Apex. Obviously, throughout the session, you'll see me looking this way. That's where my laptop screen is. Camera's over here. So I'll do my best to keep an eye on the chat and things like that. I should have actually said, sing out if you can't see me, sing out if you can't hear me. Quick chat of the chat, and no one's screaming out. So I think we're okay. Welcome along. Let me share some slides and we'll give you some introductory stuff and then we'll jump straight into the content. So hopefully you can see the slides. Hopefully you can still see me. I can still see both just. Okay, getting in touch with me is always easy and I love people getting in touch. Connect with me on LinkedIn, Twitter, etc., etc. My Twitter handle is Connor McDonald. For all the other socials, and it just continues to grow. Yes, you can even get me on TikTok nowadays with database tips. You can just go to linktree/Connor or just scan the QR code there on the screen and you'll get to all the ways you can get in touch with me. I love staying in touch with the community. For those new to my sessions, no need to adjust your set. You'll see all the content, the slide content, sort of shifted down to the bottom or to the left throughout the session. That's not me being dyslexic. That's just simply a case of we turn this into videos later and we put my ugly mug either at the top of the screen or the top right, and therefore we do that for a little bit of balance. So on the live recording, it might look a little bit strange, but obviously because you have your own control over your Zoom controls, you can simply drag the slider left to right, up and down, etc., to make either the slides as big as you want or as big as you want. Generally, people lend toward the slides for obvious reasons. A few bits and pieces like I like to talk about at the start of each office hours just to keep you up to speed with what's going on in the community. First thing, I do apologize for not having office hours last week, which was the scheduled time. I had some kids' sporting commitments that had to go on. So unfortunately, I couldn't schedule the time because I do these at 9 p.m. my time as opposed to during the business day. So just had some awkward components there. But funnily enough, I will share with you a funny story. There's a second reason why that turned out to be somewhat fortuitous. On Thursday afternoon last week, when I would normally be just prepping, getting ready for this session, I went to the doctor, believe it or not, to get some prescription cream for just some sore heels, literally some dry, cracked heels. They did the normal thing, took my blood pressure, took my heart rate, etc. The GP then absolutely flipped out and said, based on your heart, we think you're having a heart attack. Please, whatever you do, don't let your heart rate spike. Rest assured, if you want someone's heart rate to spike, tell them they're having a heart attack. My heart rate went through the roof. But literally for 5 hours, it was down to emergency, strapped onto a million sort of devices, chest x-ray, echogram, cardiogram, every other gram you can think of. Turned out it's all a false alarm. I have a slight heart, a sort of different sounding heart, apparently, according to the cardiologist. And so there was no cause for alarm. But yeah, that was 5 hours of my life I won't get back. And yeah, thankfully, we didn't have office hours last week. Otherwise, you would have seen me attached to a crash cart, which would have been perhaps as alarming for you as it would have been for me. But rest assured, if I do have some heart problems, I will still endeavor to crank out an office hours whenever the time arises. So things that are coming up. Unless you've been living on another planet, you would have seen all over the Oracle socials the last week or so that we've been running our second Database World, effectively an online set of cool tech content, obviously free, for you to digest. Last week we had about 2 days ago, we had the Americas one. Today we had the European one. All the sessions are there. You can still go see them now. They'll be made available on demand later, just like office hours sessions are. Lots of cool stuff there. In particular, a real sort of a change of tone or change of messaging that what we've seen for the last couple of years on the database landscape, the fact that people have been sort of struggling building applications due to the complexity of the modern application landscape. So we've changed direction a bit now. We're focusing on solely on how can we make the building of database applications easier and more simpler for people. And that's been the focus of that particular event. Hopefully you catch up with some of the replays. In terms of what's coming up very soon, we've got effectively some call for papers and some conferences coming up. HROUG coming up basically just in May. We got Apex Connect starting, I think, just next week. That's an event I've been to in the past. Fantastic event. Would have loved to have obviously gone this year, but I'm not allowed to travel yet so far due to some certain restrictions, both at the Oracle level and the Australian level. But Apex Connect, if you're in Europe, please get along to that, and especially if you're an Apex person. The DOAG conference call for papers ends today. So as soon as this office hours is finished, I'll be submitting a paper on the last day today. The DOAG event, one of the biggest user group events in the world. And yeah, if you're in Europe, once again, get along to that. I think it's in September this year. Normally it's closer to the end of the year. So this year it's a little bit early in the year. So it's not going to interfere with things like Thanksgiving and Christmas and all that kind of stuff. So get along to that. Submit a paper if you're a speaker. I'll be talking at SPOUG. That's a virtual event coming up in June. I'll be talking about some cool 21C features and maybe looking even beyond 21C for what's coming up. Kscope shortly follows that. I'm lucky enough to be going to Kscope this year over in, Texas, I think. So yeah, second time I've been to Texas. I went about 20 years ago for a hot sauce conference. But yeah, Kscope will be huge, a lot of fun. I've seen the agenda for that. I think it's out now. The agenda is just jam-packed with some amazing stuff. So hopefully anyone that's going to Kscope, please come along, say hello. We'd love to catch up face-to-face. And then hopefully later on in July, after a long hiatus, Sai from the All India User Group has invited me back to go to Yatra. Yatra meaning a journey, I think in Hindi. And yeah, it'll be this kind of trip. We roll up in India, a group of us speakers, both ACEs, ACE directors, Oracle employees, etc. We land in Chennai, and then literally in the space of, I think, 6 days, 7 days, we do 6 cities. So it literally is speak during the day, jump on a plane, go to the next city, speak on it, go to a plane. It's absolutely hectic, but it's just a fantastic way of meeting all the amazing Indian community in terms of Oracle. Finally, a little bit of self-promotion. Oh, there's something on the chat. Yuda says she can donate a heart if I wish, but so any heart donations will be lovingly accepted. If anyone's got a spare liver, that'd be useful because I've certainly abused mine over the years. Podcast, as always, I've got another episode out, Back to Basics, Normalization. In fact, when I wrote this slide tonight, I suddenly realized I recorded this podcast a week or so ago, but I've yet to actually upload it. So that's actually not there yet, but when office hours is finished, or maybe this week I'm going to get some free moment, I'll actually upload that podcast so it's actually publicly available. A bit silly of me there, but that's the next one. We're going back to basics on how normalization works. If you've been on my office hours sessions, you've seen this slide many, many times. I've been urging people to go out and get themselves vaccinated because communities are coming back. We've got face-to-face events happening, etc. I wanted to dwell on a moment to really emphasize this point because, for example, here's a classic example. The Greater Lakes Oracle Conference, this would normally be in my little bits and pieces section at the start. I've put it here because this event, which was scheduled for a couple of weeks' time, to my knowledge, I think has had to be cancelled simply because people couldn't get there and hence the registration numbers were low. So I think we're coming out of a period of 2 years of virtual events, and it's very easy to lose track of the fact that the thing that really inspires passion in what you do for a living, whether it's Oracle, whether it's something else, is the ability to regularly meet up with like-minded people. I love doing this office hours session, but the reality is, if I was in, say, Uruguay, the first thing I'd be doing is I'd be giving Edelweiss and Nelson a big hug, and just the act of doing that would get me inspired to do more learning, more education, more work with the Oracle toolkit. So it's the ability to be with people face to face to share that passion that's going to really, make you successful in your career. So I can't stress enough, user groups have had a horrific time the last couple of years. So get out there, support your local user groups, and whenever they're having events, just make that effort to get along because ultimately we all win in the long term when we do that support of the people that are primarily doing volunteer positions. So as I said, support your local user groups. They're vital to our success. as a industry. So what are we talking about today? What are we talking about today? I'm going to talk about some format mask issues, some sample schemas, text indexes, how synchronization might be broken, how to do Google-style search on Oracle, how to sort bad data, and deleting old records. These are questions that have come in from the community, and so hopefully if you ask these, you're on the call. If not, I'm sure you'll catch the recording, but we'll tackle these 6 things if we get time once I stop pontificating about all the goodies in terms of the Oracle community. Oh, lost my pointer. So, format mask case. Let's talk about this question. We have a function-based index to improve the performance of date queries, which are based as string or phrased as string predicates. It does not work when the case of the format mask does not match that of the definition of the index. Is there a solution to this bug? Now, that sentence, the best way of describing this is simply to focus in on this particular part. Date queries which are phrased as string predicates. Well, in a previous life, when I was perhaps a bit more vindictive and bitter, I would simply say you get everything you deserve when you start playing with the wrong data types for handling dates. We've done office hour sessions before about using the right data type, but in this case, I would imagine our poster here is stuck between a rock and a hard place. They've probably got perhaps a vendor system or something where the SQL is being generated. And therefore, I would imagine anyone that goes and puts a function-based index on a table to solve these kind of issues really hasn't got the ability to go tackle the SQL itself. It's probably being generated by some reporting tool, etc. So here's what this person is encountering. They've got probably some tool that's generating queries that looks like this. Select star from some table where toChar of a date column equals some string. And what they did was they had to try and come up with a way of optimizing this, and they're having some problems. So I've got a demo here. We'll do our first demo of the evening, and we'll have a look at what the issue was and ways that we might consider solving it. But all of this comes with a caveat of course, ideally, the best data type to use for dates is the date data type, naturally. And the best way to reference dates in the database is using date data type in your predicates, in your expressions, etc. We're going to work on the assumption that that is not possible in this case. Let's see what we can do to improve the situation. Okay, hopefully that font's large enough for everyone to see. So first thing I'm doing is I'm creating a table which is going to be our table we're going to do our queries against. In the Scott schema, it's called Big Tab. And all it is about 100 or about 1,000 copies of the Scott.emp table. And you can see I've simply picked a particular number to make our screen output look nice and clear here. I've got 140,003 rows in this table. I simply chose that. That looks like a weird number. I chose it such that when we do some queries here, we don't get pages and pages of results. We get nice, simple results. So we can see the date range here from 1st of January 2020 to 27th of September 2022. So let's first of all look at a simple query which uses what we're meant to be doing when we deal with the Oracle database. I'm doing select star from big tab where date greater than or equal to this particular date string. This is good queries, good SQL coding. I've got the date data type on this side, date data type on that side. I get 4 rows back. But even with good query semantics, I can see this query is doing about 23,000 physical IOs, and I would like to improve that. And what will we do when we have simple queries like this? The most obvious thing we would do is throw an index on that particular date column. I rerun my query, I get the same results, but now you can see the performance is dramatically better. Obviously in this demo, everything's nice and fast because 140,000 rows is nothing for an Oracle database, but you can see we've actually dramatically lowered the cost of satisfying this query with the addition of an index. If we look at the execution plan for that, you can see we did index range scan on this index that we just created, just to prove that there's no smoke and mirrors here. So moving on to our posters query, moving on to the issue of what happens when you actually don't use date data types and you're using strings to do string comparisons. So in this case, I'm saying select star from scott.bigtab where toChar the date equals some nominated string. Yes, the query still works, but we're back to the 23,000 IOs. Even though we have an index on the date column, the moment we put an expression around that column, then all bets are off when it comes to the index. So this is one way, if you don't have control over the SQL, of perhaps trying to tackle this problem. What I'll do is I'll create a function-based index on the typical expressions we're going to be using in our where clauses. I've got effectively create an index on toChar of the date column and then our nominated format masks. I'm using YYYYMMDD here just so it's easy to read. Now when I run these queries, select star from scott.bigtab where toChar date column using that same format mask greater than this. Nice simple result, and you can see by the physical reads that we're most likely using the index because it's no longer doing 23,000 IOs. Here's where things get a bit weird though. I'm doing what is semantically the exact same request here, where toChar date YYYMMDD equals some string, but this time I'm back to 23,000 IOs. The only thing I changed was the case of the format mask. But the database doesn't really know that this is obviously the same meaning as having uppercase on that particular format mask string. It simply compares that expression there with the definition in your function-based index, sees that they're not the same, there's simply a difference in case, but that's enough to be different, and therefore I can no longer use that index. This is the problem that's come in. If someone has this variability in the format mask, how can we still take advantage of that index? I could create another index on here as well, but then I'm starting to rack up indexes to handle all the permutations of format mask case that comes in. One would hope you can get some consistency, but in this case, you might not. We can see it's doing table access full. So how do we tackle this? What I'm going to do is use a technique that we've seen in other office hours sessions from time to time. And this technique is to use the SQL translation facilities. The way that I'm going to do that first is I need to create a package which takes two predefined routines. Translate SQL and translate error. We don't need to worry about the error. We just worry about translate SQL. It takes a SQL statement in as a clob and sends a translated SQL text out. SQL translation was originally designed to let you do effectively non-Oracle queries against an Oracle database in terms of, for example, like migrating from, say, Postgres or DB2 or SQL Server to Oracle, but you can use it inside the database as well. Here's my package body. Now, I'll return to this later and talk about the fact that it's not totally complete, but let's walk through it nice and simple. I'm creating a list of mask components here that we'd normally see in the format masks. We might see YY, MM, DD, etc., etc., etc. I'm then going to walk through for each of those different elements, and every time I see that in my SQL text, I'm going to replace the translated text with the upper of that. So if I get a lowercase YY, by the time I translate that SQL, it's going to become an uppercase YY. And there's my package body. How do we wrap all this into a SQL translation profile? What we do is we create a profile. I'll call it demo profile. We set the attribute, which says, yes, it's not foreign SQL syntax, it's Oracle syntax. And then I say, this is the package I want to use to do the translation. Once I've done that, I will allow Scott to use it because my queries are against scott.bigtab, and I'll set the SQL translation profile to this profile I've just created. So let's go back. Here I have select star from scott.emp where lowercase YYMMDD. Let me go back again. I'm starting with a very simple query first, not big tab. I'm just saying, let's see if my profile actually works. I'll just do scott.emp where toChar hire date is something like this. I see, was it translated? It says yes. Here is the actual SQL statement that was run. You can see I translated the lowercase YYs over here into uppercase YYs by the time it got into $SQL. So this simple sanity check gives me some confidence that it's actually working. Now let's give it a go against my big tag table. So here's one that's working fine. This is what my expression was on anyway in my function-based index. It's uppercase and it works fine. It's still using the index nice and quick. Let's now throw a lowercase into it, and we can see it was incredibly fast. It came back with the exact same speed. So even though I passed in a lowercase format mask, the SQL translation framework has grabbed it, converted it to uppercase, which means it can now use the index that we previously defined. So the SQL translation framework might be a mechanism of actually being able to dynamically replace those lowercase format masks with uppercase ones. Now you might be asking, why didn't I just do, effectively look for YYYMMDD and convert it to upper? Or why did I look at the components? Why not I just change the whole thing to upper? Well, you need to be a little bit careful. And even my package as it stands here is what I would call incomplete. You need to be very careful when you're picking apart pieces of a SQL statement and you're going to actually dynamically change them. What if one of the column names, for example, had YY in it? What if some literal text in one of the predicates had YY? So you need to be careful as to which parts you actually replace. Here's an example just to show why you need to be very careful. If I turn my profile off, so it's just back to normal operation, and I do select star from scott.bigtab where uppercase Y's, lowercase mon, uppercase dd equals 22nd of September 27, then that returns some rows. If my profile was active and I came along and uppercased everything that I found in the format mask, but didn't change that, then I'd get no rows selected. So I need to be very careful what I actually go through the SQL text. And even my package is probably incomplete. I'd actually need to go look for things like, where does the toChar start? Where does it finish? Only look for format mask elements within that range, etc. I was pretty lazy here. I just simply said CLYY, bang it to uppercase. That's probably not a sufficient solution, but it was simply for the ease of demo. But you can see here it's important that you can't just go replace everything in a format mask to uppercase, because there are some elements in a format mask, like the actual literal month, which aren't going to work if you simply convert them. You can only convert those elements in this case, which are going to represent numerics. So it's important that you are very careful with your translation. So hopefully that makes sense. If you can't go and actually correct the SQL, and please, that should be your first port of call, but if you can't, if you're having these kind of problems, sometimes things like SQL translation frameworks are a sort of tool that wasn't originally designed for that purpose, but a way of just tweaking an SQL to make it suit your business requirements. As I always say, the best uses for a lot of Oracle tools aren't always what they were intended for, but for exploring solving business problems, because ultimately that's what we are as IT practitioners. Our job is to solve problems that our business present to us. The sample schemas, those wonderful things, the HR schema, SH, etc., all the cool schemas, like the Scott schema back in the day, that come along with the Oracle database. I think they're fantastic. I do a lot of my demos off them, but here's a common question that comes in via Ask Tom or via Twitter, etc. I'm trying to install the sample schemas from the Oracle Git repository, but I'm having all sorts of problems. Can you assist? So to explain why, obviously installing schemas shouldn't be that hard, but we do get a lot of feedback saying people are having problems. Can I assist? Well, not really. And when I say not really, there's probably something that we have to explain here. So let's go through a bit of history about why the sample schemas are how they are, and why sometimes people have some dramas when they're trying to get it all sorted out using the Git repository. Back in the day, when the documentation used to be purple on white, this is the Oracle 9 documentation, but you can find this kind of stuff, I think, all the way back to Oracle 7. The sample schema, as it says here, when you do a complete installation, they are installed automatically with the seed database. And this is how it used to be. We simply put the sample schemas in there, and they simply ran. If you opted to not have them, but wanted to put them in later, the tool you used was the Database Configuration Assistant. That was the recommended way. And here we have it. So using the Database Configuration Assistant, you fire up the GUI and you click the sample schemas and you hit go, and it took care of the whole job for you. And the reason it did that is, by and large, the objective was to install the whole lot as a unit. And in fact, you could see the actual various bits and pieces here that were required when you actually wanted to install the sample schemas. If you wanted the order entry schema, well, you had to make sure that spatial was installed as well. If you wanted, for example, the order entry schema, well, the first thing you had to do was make sure that HR schema was there as well, because they had dependencies. If you wanted the product media schema, well, that needed the order entry schema. And of course, the order entry schema needed the human resources schema, and so on and so on. Because this thing was originally designed as you tick a box in the database config assistant saying, yes, I want sample schemas, they've been wrapped up and bound up together effectively as one single parcel. And the way they were configured on your Oracle file system where your software is installed was such that the database config assistant could install it in the most easy way for it, not necessarily for you. So in reality, the sample schemas were an all or nothing kind of exercise. And that's a big deal because sometimes you didn't want all that kind of stuff because the sample schemas are designed to give you examples across the length and breadth of all the Oracle functionality, which means it's got a lot of stuff in there. Now, two things changed between Oracle 9, obviously, and where we are today. Number one was the push for lightweight. Things like Oracle Express Edition, the ability to run Oracle in Docker, meant that a lot of people were saying, look, I'd like an Oracle database image that is stripped out of all the stuff I don't explicitly need to run, for example, say a unit testing framework or a lightweight production or an embedded system, etc. Sample schemas is one of those things that you probably want to turf out. And the second change is obviously the world moved to, well, you don't get stuff on CD anymore. You don't even download stuff that comes with your software product. Generally nowadays, everyone puts their stuff out on a Git repository somewhere. And that's, the modern thing. Like my office hours scripts are sitting out there in Git somewhere. Pretty much anything, any kind of software material that you want to actually give to the world, you generally put it on a Git repository somewhere. So the push for lightweight meant we took the sample schemas out, and the push for Git, the move toward Git, means we've put them into the Git repository. And that's where they are. If you didn't know, the sample schemas now you won't find on the software. You won't get them downloaded from Oracle Technology Network. You simply go to the Oracle Git repo and look for DB sample schemas, and it's all there. You download the zip file, and away you go. Now, it's that away you go part that creates a bit of consternation when people try to actually do this. And the reason for that is at Oracle, we're faced with a bit of a problem here, and that is the way the sample schemas were originally packaged up, their file structure was obviously designed for the database configuration assistant to actually sit and use them. And once it was installed, it would all sit under Oracle Home/demo in your old Oracle software distribution. So people who have grown up loving that format and that structure, or have written scripts based on that structure, well, we need to preserve that intent. At Oracle, we love to be backward compatible as much as possible. But what about new installations? Well, that layout is probably not ideal for people who have never used the database config assistance. What about cloud? Some of the things in the sample schemas are explicitly designed to run on local file systems, like it does things like SQL Loader to populate some of the data. You can't do that on cloud. And then we get things like clients. Some people say, well, I don't want to have a database installation to install the sample schemas. I've just got Instant Client that's talking to a database that already exists. Can I get the sample schemas installation to run under Instant Client? So there's all these variabilities now that we've tried to satisfy and putting it all in the Git repo. Oh, what did that happen there? As a result, the README file under the sample schemas is fairly detailed, and there's a whole stack of steps you have to go through, and a lot of these things are preliminary steps. You have to go edit some of the files to make sure it's all going to work before it installs. That's challenging for number one, because people like a sample schema to be like, can I just click a button and I get them? And now we're saying, look, here's a whole stack of stuff you have to do. And similarly, the requirements inside that installation script may not suit your particular needs. For example, you need sysdba access. You obviously don't get that on cloud. There are various things that you have to be able to run, like things like dbms apply, dbms capture, dbms flashback, dbms stats, select any dictionary. That's because these particular schemas have some very high-powered demos, things like AQ, messaging, propagation, streams, etc. Some of this stuff you probably don't want just for simple sample schemas. We create nested objects and object types. We do XML schema registration. We actually have things like directory objects created, and effectively things like this, directory objects from these particular file systems, some of which you'll have on your own system, some of which you don't get on cloud, etc. So in that README file I scrolled through, there's instructions saying, if you're on cloud, you have to do this. If you're not, you have to do this, etc. After all that, people just go, it's all just too damn hard. I just wanted the HR schema. How hard can it be? So, point taken. For a lot of us, we just want the HR schema and the SH schema. They're the probably two most common. And also we have a CO schema for customer orders, which is JSON specific. But those three are probably the three that are most in demand, and getting them to work under that scenario can be challenging. So if you are struggling, what I did was I went through all the the various subscripts that are called and all the bits and pieces and merged it all into one script called HR Quick Start, which you can find in my Git repo. So let's give that a run and see how it works. So one of the cool things that hopefully that you'll like about this script if you run it is it does its best to save you from yourself. It's going to do a whole lot of stuff beforehand to make sure that hopefully when you install this thing, it's all going to work. So the first thing it's going to do is make sure you're actually connected. And then it's tell you, if it says, if you get this message, you're obviously not connected, hit Control-C and make sure you connect. It's going to give you some hints about what your connection string should be. Then what it does is it says, can I write to the file system? Because it wants to spool out the log file. It checks to see if it's a container database or not. If you're not a container database, that's fine. If you are a container but you're in the root, it's going to error out and say you can't do it. It's going to connect. It's going to say who you're connected as. If you connect as the existing HR schema, it'll simply drop the objects and reinstall. If you're not connected as HR, it'll drop the entire HR schema and then reinstall it from scratch. And then what it does is it goes through and says, let's make sure all the privileges I'll need to install it as a DBA are actually present in this session. And then it checks things like your table spaces, checks the existing stuff, etc. And then that's going to be my new password. I don't care. I'm not going to connect at the end. And hopefully, there we go. Off and runs. It chugs along. And at the end, it does a little check to make sure all the objects are there. And it says installation complete. So hopefully, literally one and done. And the whole way, it's guiding you through to make sure that your connector is the right person, that you got the right privileges. It's going to tell you how to resolve those things if you haven't got them. It's just literally one script, and it's a warm and cuddly script. It'll help you, it'll hold your hand through the whole process. They're on my Git repo, so go to GitHub, Connor McDonald Miss Scripts. There's one there for HR, one there for SH, and one there for CO as well. I didn't do the other scripts, the IX schema and a couple others, because generally they're for stuff that isn't going to run across all databases. It'll only run on some it'll only run on Enterprise Edition, others won't run on XE, other ones that won't run on Cloud, etc. And hopefully they're the schemas that you'll most frequently need. A word of warning, the SH schema is a data warehouse schema, and to make sure that could run in a single script, I had to do a huge amount of insert statements. We couldn't use SQL Loader. I didn't want SQL Loader being on the dependence of the critical path. So it literally is just one single SQL script. So it's got like 100,000 SQL inserts in there. So it runs a bit slow. But like you just saw there, they literally are just one and done, and your schemas are there. So hopefully that makes life a lot easier for you. I will say stay tuned. The whole sample schema sort of concept is being rethought within Oracle. Such that there will be facilities either cloud or on-premise where you can literally, for example, typically from a tool, say from Ords or from Apex or from SQL, you can just go something like, give me the HR schema, and it's just going to do it. So hopefully we're revamping all this stuff. But in the meantime, these quick start scripts will hopefully make your life very, very easy. Question number 3. Index sync is broken. Here's the problem that came in. As per the docs, we query the CTX user pending view or table to see if our index needs to be resynced. They're talking about here about a domain index or a text index. We have recently upgraded to 21C. Good for you. And the view is broken. Sync still works, but we now have to do it constantly because we can't see if we need to. They're saying that CTX user pending is empty. I love this little sort of, little barb, as per the docs, that's why I highlight it. They're simply saying, yes, I've read the documentation and it says I should query this view and this view should contain all the pending rows that are going to be synced, and it doesn't. Now, one of the things I should note is index sync is not broken. And they did say it actually sync still works, and that's true. And index sync still works very, very well. And in fact, we've made it a whole lot better in 21C, and I think it's being backported to one of the later RUs in 19 as well. But I will take this person's point. If you do look at the 21C documentation, it says, here's the view CTX user pending. This view displays a row for each of the user's entries in the DML queue. It can be queried by all users. So the theory is, if you have made some DML changes to a table that has a text index on it, you can see what rows need to be resynced by querying this view. And then when you resync the index, that view becomes empty again because everything's up to date. So I'm imagining here the original poster is what they're doing is they're saying They probably don't have a scheduled job to do the sync. What they do is, they might have infrequent updates. So what they do is they query this view. If it's not empty, they'll effectively run the sync. Otherwise, they do nothing. I'll take your point. I have logged a documentation bug saying that we should not talk about CTX user pending in 21C because the fact that it's empty is deliberate and by design. It is no longer used in 21C. To explore how we do it if it's no longer in that view, we have to run a demo. Let's give it a go. So I'm going to connect to a few different databases here. So each time I'll spit out the banner so we know where we're on. So I'm on 19C here on this local machine. I'll create a table, very simple, just a copy of scott.emp, and I'll put a text index on it. So this is a text index on the ename column. Obviously, that's probably not the most exciting column to put a text index on. Not a lot of document content in that ename column, but it serves our needs. If I insert some new rows, and I've simply taken the employee name and appended an X to them, so we know that they're all different rows. If I do a query on the CTX user pending table, what I'll do is for every column that comes out called PND row ID, I'll store the value in sample row. First, I'll query CTX user pending. It says I've got 14 pending things to be synced. My index is not in sync with my table because I've got 14 outstanding entries, that being the 14 rows I've just inserted. The fact that I've asked the database to store one of these rows in the sample rows means I can now say, let's grab one of these sample rows. It simply remembers the last row ID. And just to prove that those 14 rows are the ones that need to be synced, you can see that one of these 14 is Miller X because we did this appending the X at the end. So there's 14 rows here. The 14 rows with the employee name has got X at the end of it, and they are waiting to be synced. Let's now do the exact same demo, but against Oracle 21. 21C on the same machine, create a table called T, it's a copy of scott.emp, create a text index on it, exactly like the previous script we just saw, put some rows in, once again with the X on the end. Let's query CTX user pending, and it's empty. And that's what caused the issue here for the person that raised this question. How come I'm not seeing the pending rows in CTX user pending? In 21C, they don't go there anymore. Let's see where they do go. First of all, let's have a look at CTX user indexes. Maybe there's some clues there, but you'll find nothing in there that's useful. It says that we have 14 entries indexed at the moment. We know there's now 28 rows in there, the initial 14 plus the 14 we just inserted. So there's nothing in there that suggests that there's any outstanding DML. If we go back to Oracle 19, when you create a text index, we create some subordinate objects to support that. In fact, we can actually see the index was called TIX. If I search for all the objects that are $TIX, we can see that in Oracle 19, we create 4 subordinate tables, and there's some indexes underneath those as well, to support your text index. Let's now go to Oracle 21, and you'll see that things have changed. We've done a fair bit of re-architecture for Oracle text indexes. Now, when you create that index with TIX, you get 7 subordinate tables floating around. So there's a lot more stuff going on under the covers here for text indexing. If I query those 7 tables, and I've sort of consolidated them all to one query here so we can get it all in one row, you can see there's no rows in the N table, there's no rows in the B table, there's 14 rows in the C, 14 in the I, 14 in the K, none in the Q, none in the U. So that's the counts in there at the moment. Remember, I had 14 rows that I'd inserted, but I couldn't find in CTX pending, and I hadn't actually resynced the index now. So I'll resync that index, which will bring that index up to date. It's now in sync with the table, and I'll rerun that same query. Let's now do a bit of compare and contrast. The number of rows in the N table went from 0 to 0. No change there. From B, 0 to 1. From C, 14 to 0. I, 14 to 28. 14 to 28. 0 to 0. 0 to 0. If looking at these numbers, I'd be making a guess that it's probably the C table that might contain the pending rows, because it had 14 rows before I did a sync on the index, and now it's dropped to 0. So my guess is that those rows, probably the pending rows, go in here as opposed to CTX user pending. Let's test that theory. Let's insert another 14 rows. This time they're all ename with a suffix of Y. And now let's query this table, this $TIXC table that I suspect contains the pending rows. Well, there's 14 rows in there. That looks promising. Same thing here. I'm preserving one of them in the variable sample row. Let's pick it out, one of those rows. And it says, yep, one of those rows, this last one here, is Miller with a suffix of Y, which equates to the ones I've just inserted. So it's reasonable to assume, I think, that instead of rows going into CTX user pending, now they go into one of the subordinate tables, which is index name with a $, suffix of C. That's where our pending rows go. And that's where you'll find them. So all you do is need to change your procedure. Rather than look in CTX user pending, simply look in the C table under your index, and that's where you'll see your pending rows. That's not the only thing we've changed in 21. And here's a little sidebar here, which hopefully will get you excited about text indexes in 21C. I've gone back now to Oracle 19. I create a table called T, brand new table, TIX index, so it's a brand new object again. Let's insert 14 rows, and you can see as we selected, they're all there in CTX user pending. So this is an open transaction. I've inserted 14 rows. I've got 14 rows in my pending table, which are there waiting to be synced. Let's go to 21C now and see that same demo. We know they're not going to be in CTX user pending. They're going to be in that $C table. Create my table, create a text index on it, insert 14 rows, and I know that to find those pending rows, they're in the $C table, and it's empty. That's a bit weird. Didn't we just show in the last demo that they're in there? I haven't ended this transaction yet. When I commit, then they appear. So unlike in 19, as DML is occurring, we store rows in the CTX user pending. In 21, we wait till the transaction ends. We're doing some batching of the ingestion of rows such that we can get them very rapidly into here. It's not like having a row level trigger. It's actually, we're deferring that work until you commit, and we can put the rows here in batches. So we actually get a performance benefit as well when you're using 21C text indexes when it comes to the regular DML that occurs on tables. Let's go back to the slides. So why'd we do it? Well, text indexes have got very, very popular. They used to be, people didn't used to use them that often. Now they get used everywhere. And as a result, when you have dozens of tables all smashing rows into CTX user pending, it becomes a contention point. By moving the pending DMLs into the tables that sit underneath each individual index, we've spread that contention load out. We've removed the contention issue from CTX user pending. And as you just saw, we've dramatically improved the ingest rate. Now, it's not like having a row level trigger. Every time you do ML, you have to stick something in TTX user pending. Now we defer that work until you commit, and we can do it in batches, a bit like the fast memory ingest that came in 19C as well. So we're doing better ingestion, better DML performance, and removing contention. So text indexes in 21C are dramatically improved on all previous versions. 9:44, we might get another one done. Yeah, Q&A, we might not get another one done. Is that 21 feature going to be backported to 19C? I don't know, to be honest. I wouldn't be surprised because text indexes are incredibly popular, and you probably would notice if you're on Autonomous, you don't get 21C as an offering because it's not a long-term support release. So don't quote me, but I wouldn't be surprised if some of this stuff ends up coming back as an RU into a later RU for 19, like 1917 or something like that. No promises, but that would be my guess. Since we're on the topic of text indexes, let's talk about Google search for Oracle. We'd like to give our users the ability to find a term anywhere in our application. For example, if they enter an invoice number, it would look in the sales table, look in the feedback table, in the cancellations table, and this, as I said, sort of like Google, but for our application. Is this possible without writing a massive SQL to do that? And the answer is yes. And let me give you a couple of examples which often satisfy any need you have, and then we'll walk through a demo to see how we'd actually do it. Probably the first and most obvious example is something like Apex. If you go into Apex in an interactive report and just type in sales, you don't have to type in, oh, I want where sales is in DNAME. It simply looks anywhere along the row to find the term sales and just does it. That's very impressive from a UI perspective. Under the covers, we're doing effectively what you would do if you wrote the SQL yourself, which is, besides all the normal Apex stuff, it's simply as building a where clause saying, can I find the term sales, in this case a binary variable, in the department number column, in the department name column, in the location column. So it's not necessarily going to be a magically efficient mechanism. If I go back one slide, it's effectively looking at all the columns which are on display and then building a query which simply says, can I find the term you nominated in any of these things? So most likely you're going to be doing a full scan of whatever the result set is potentially going to be. So if that's the only criteria, you're pretty much going top to bottom through the table. But for small tables, that works perfectly fine. Apex, interactive reports, interactive grids, etc. That's how they do it. How about this example now? If you go into Ask Tom and type in a search term of codeine, a sort of pain-killing drug, it finds a result. If you click on that, you won't see it in the question. You won't see it in the answer either. You have to scroll all the way down into one of the comments, and there it is, the term codeine. Now, the reason I know that was going to work is I had to go into an Ask Tom question today and enter a review saying codeine, so I know this would come up just in the one question. But it does raise the, no pun intended, question. How did it find the word codeine when I searched the questions, even though the word codeine was in the comments? We sort of have this issue. In Ask Tom, we want to be able to search for the term codeine both in here, both in and arbitrary many comments as well. And you'll just have to take my word for it. I didn't write an SQL that says look for it in here and look for it in there. What we do is we use Oracle Text to do a Google-like search. And Oracle Text is very cool at doing this. And let me show you a demo on some simpler tables with what we do in Ask Tom. So for the purpose of this demo, I'm going to have the department table and the employee table, which is a child of the department table. And I'm going to put a Google-like search across both those tables. So here's select star from Scott.department. I'm going to create an index on the department name column, and it's a text index. Now, I can do look for, using the text index sort of syntax, contains department name research greater than 0, and I get a result. Now, that's hardly profound. I mean, I put an index on the dname column, I searched the dname column, and I found something where the dname column matched it. I mean, that's really no great benefit there for a text index. I mean, I could just use any old index. And similarly, if I search for dname of Dallas, which is a location, well, that doesn't work. So it seems a bit silly here. Like, what benefit have I got from having a text index on this thing? One of the benefits of text indexes is because they're what's called a domain index, you have some control over how the index is built. So the first thing I'm building here is a procedure called scott.getDetails. Now, it has to take a particular two arguments. One is a row ID and one is a clob. And we'll see what happens. What happens is a row ID comes in from your table that the index is on, and then you build a clob, which is a list of terms that will go into that text index. So in this case, whenever a row ID comes from the department table, I'm going to use that row ID to query the department name, the location, and all the employee columns for all the employees that work in that department. And I'm just going to append them all, space delimited, into this lob. So effectively, I'm building a list of all the employees, all their employee salaries, all their hire dates, all their et ceteras, and all the department rows as well, and putting it all into a big long clob, and that's what comes back from this routine. Then I can use what we call preferences to tell the Oracle database to use that procedure when we build a text index. So I say create a preference called search IDX DST for data store. It's a user data store. And then I have this attribute is this procedure I just built. So I'm creating a thing called a data store. And part of that data store is a procedure called scott.details. I drop that index I previously built and recreate it now. Once again, I'll put it on the loc column this time, location column, saying use this data store I just created. In the building of this index, it took each row ID from the department table, passed it into that procedure, which then went and got all the department details and the employee details for those departments, built it into a clob. All those clob terms came back and got used to put into the index. So now, if I do a select star from scott.department, that's what the table looks like. I can do select star from location, Dallas greater than 0, and that works fine, but you'd expect it. Dallas is a location. This is the column which is indexed. That's hardly profound. In fact, it looks just like that. I mean, how is that different? But how about this one? I can do select star where location and sales has a match, and I get department 30 back. Now, obviously, sales isn't here, but remember I said this index contains, even though the index is on the location column, this index contains for each row all the different department information plus all the employee information as well. Part of that department information is the sales table, so I found sales in the location. How about clerk or clerk, depending on how you like to pronounce it? I'll pronounce it clerk. If I'm looking for a clerk, well, there's no clerks in the department name, department number, or the location. But what I have gone is looked in this index, which contains the employees for each department, and found those employees that are clerks. As it turns out, there's a clerk in every single department, 10, 20, and 30, which is why I got 3 rows back from the department table. Similarly, if I say, look in the department table in the location text index for 7369, I get a row back department 20. Why? Because one of the things in that index is employee number, and employee number 7369 is in department 20. So you can start to see we're getting effectively sort of a Google style search here, because I simply type in a term and I'm picking up that term wherever it occurs in the department table or the subordinate employee tables underneath it, because I use that user data store to pick up all that information. What if I set now, how am I going for time? Ooh, we might get through this demo. So that solves the query issue. That's fine. But what if I start doing updates? If I update Scott.department, set the location to Mexico and commit it, then my query works fine. Now don't forget, this index is on the column called location. So I change location to Mexico, it's immediately updated in the index, and that works fine. What if I update the department name to, say, lab work from research? So changing the research to lab work. When I query my index now, it didn't work. I'm expecting to get a result there because lab is obviously a subset of lab work. I didn't get it. This index is on the loc column, and the database is, I'll put it in inverted commas, smart enough to know that only when you change the loc column should I need to change an index on the loc column. But it doesn't know that, by the way, we're building all this other information and bolting it onto this sort of text index on the loc column. For example, if I rebuild the index now, which rebuilds it from scratch, now I do find the lab work in there. So if I rebuild the index, it will pick it up, but it didn't pick it up just by doing an update because it didn't recognize that I had changed the loc column because I hadn't. We can prove this. I'm going to reset them back to Dallas and research. That's what they were when we started. LabWorks disappeared, so it's gone. If I update dname to LabWork and set location just to location, I haven't changed it, but I've told the database that location has changed. When I commit, now I do find it, even though I only changed the department name. The database saw this and went, oh, you've possibly changed the location column. My location column is indexed. I better add that row to the index to be resynced. So what I need to do is make sure that I always update the location column because that's what the index is on. That becomes a bit fiddly. So how could I do it? Well, what I could do is every time, I've called this trigger department tickerly index. Every time I change Scott.employee, no matter what I do, I'll update the location to itself for any of the department numbers that have changed because they're the primary keys. So whatever department number, department rows have changed, I'll update location to itself. Therefore, it'll tickerly index and make sure it gets resynced. Anyone see an issue with that? Of course, we get this. I do a trigger on the Scott.department table, and I'm trying to update the Scott.department table inside the trigger. I get table is mutating. No problems there. We do the old trick. We simply say, let's do a compound trigger. We'll, at the row level, remember all the rows that we need to change. And then in a statement level, after the work's been done, we'll go ahead and update it as well. So that'll fix the mutating trigger, of course. So anyone see a problem with that? Nobody? Oh, no one's brave. I try update that one row to lab work again, and boom, it blows up. Why? I'm updating the department table. The trigger says at the end of it, update the department table, which guess what? Fires the trigger, which says update the department table, which fires the trigger, and I get 50 rows deep in my trigger before the thing blows up. So I have a bit of complexity here. Now I need to know if I'm updating the department table by itself or whether I'm updating it inside the trigger. So I'll create a little package called Scott in trigger. Am I already inside a trigger? And I'll amend my trigger now, my compound trigger, which simply says, if I'm not already in the trigger, then I need to remember what changes I've done. At the end of it, if I'm not already in the trigger, then do some changes and make sure the trigger doesn't fire for these changes so I don't get stuck in this recursive loop. Then when I do it, I say update to set department equals 20. I haven't touched the location column, but the trigger will give it a little tickle and therefore it appears in the index. So it can be done, but you need to take a little bit of care. A few minutes left. I've got a little bit more of this demo to go. Let's set it all back to normal. What about the employee table? Well, I'll insert a row into the employee table. That's a brand new employee called Connor. And as you can imagine, the department table has no knowledge that that's gone on. So I need to do the same thing. I'll delete that row. I need to put a nice big trigger in place for the employee rows as well. So every time I delete or update, insert, or delete an employee, I need to find out the department number of that employee and then tickle the department table as well. Put Connor back in and select it, and there we go. Connor works in department 10. So there's some nuance involved because you need to know where the index is defined and know what other tables need to go tell that index to make sure you stay in sync. Now, this is only if you want to handle DML. It might be the case that your data is mainly read-only, or it might be the case that you're simply going to resync once an hour, once a night, etc. But, or rebuild. But you can do it with triggers if you need to. Let me drop all that, clean it all up. Let's finish with one last thing that you might find really, really useful in the more modern version of the Oracle database. This will be our last demo because we've only got 2 minutes left. Rather than building a TLOB with all the attributes simply space delimited, I can take advantage of some of the JSON cool stuff we have in 19C and above. Here's my procedure Scott got det details again, still takes an row ID, returns a TLOB, but that TLOB will be a JSON aggregate of the JSON object of all the bits and pieces from this tables. So rather than returning a TLOB just with space delimited values, I'm actually building a JSON fragment which contains all the information for this department and all the employees for that department and all the columns from the employee table, all in one big JSON. And that'll be the input to my text index. Oh, what have I done there? Oh yeah. So I tried that. So I thought this is an error, but it's not. This is part of the demo. So I've done that. I try build my text index on the location column using the create search index clause, which came in 19C. And it says you can't do that because you can only put a JSON index on a column which is JSON. And my location column obviously isn't. So how do I solve this? What I'll do is I'll drop the index. Notice I use force here. This actually created part of the index. So when you want to drop a text index, you have to do drop index force because some parts might be hanging around. What I'll do is I'll add a column called JS for JSON. And I'll put a check constraint saying, yep, that JS column is always JSON. It's null. I haven't set it to anything and I never have to touch it. I just have to make sure I've got a check constraint saying that's always JSON. Now I can create my text index on this column. Even though it doesn't look at that column, our user data store procedure simply says all I care about is building that JSON fragment on the other columns in the department table and the employee table. But I've built that. I'll make that column invisible now so no one knows it's even there. And now I can start using JSON searches using a text index and get the same information. Let's look for anything anywhere in the JSON that contains 7369. Employee 7369 works in department 20. Let's look for just employee numbers that are 7369 and I get the same result. But now, because it's a JSON structure, I can now go into the JSON fragment itself. For example, if I look for $.ename, then I wouldn't get a match there. So you immediately see how much more powerful this is because now I'm no longer just looking for terms randomly. I can look for terms randomly, but I can also look for terms within particular attributes as well. So a few things to note, and then we're done. Obviously, there's some locking implications there. Notice my trigger, every time I change an employee row, I updated a row in the department table. So there are some locking implications there. You need to be very aware where your index is defined, because that might be involved in some locking restrictions that are going to come along, because you need to tickle the appropriate rows, so to speak, to make sure that index is synced. The invisible JSON column is an interesting one. If I add the column as JOS, add the column like I did in the demo, add the constraint, create the index and make it invisible, that's fine. So you would expect if I simply added it as invisible and then did the same thing, it would work as well, but it doesn't. There's a bit of a bug in the processing that simply says, I can't add a JSON index onto a JSON column if it's invisible, which is bizarre because obviously if you flip it around the other way, it works just fine. So be aware of that. It's a bug, but at the moment you have to make the column visible, build your index, then you can make the column invisible. But the best thing is all the normal goodies that apply with text indexes still apply, even though you're building this Google-like search. So you can sync on commit like we saw there, or you can do it in a deferred fashion. You can do fuzzy searching, generic terms. You can have case insensitive, case sensitive. You can have stop lists to make sure certain things don't get indexed. You can do, wildcard searches, substring searches, all that good stuff that comes with domain indexes generally, you can do if you're building some sort of Google-esque search on your database applications as well. We're done. The hour is up. We didn't get through all our questions, but hopefully you found all that stuff interesting. As always, if you have any questions, grab me on Twitter. Always happy to talk tech. And as always, this recording will be put up as well if I went too fast through some of the stuff. Let me reiterate just one more time. Forgive me for being a broken record. As always, if ever you get a chance, please get out, support your local user groups, get along to their local meetups and events. And I'm not being an Oracle bigot here, whether I don't care if it's a SQL Server event or a Postgres event or a Kafka event or anything. Anything which is a tech event, please get along, support those groups, because that's how we're going to keep our communities inspired, keep them strong, and that's how we prosper, all of us, in our IT profession. Thank you very much for your time. I hope you enjoyed the session, and we'll see you next month again on Office Hours. Bye for now, everyone.